Hi guys, my name is JB. I'm an instructor and pilot with DroneIt, and I want to chat to you guys a little bit about practical operations and training that we do in the practical field. So the few topics that I want to discuss is actually as follows. It's flight planning, aircraft pre-flight inspection and setup, radio calls, post-launch in-flight procedures and maneuvers, emergency response plan, post-flight inspection and practical exercises. So first topic, flight planning. Now guys, why is it so important for us to actually go out and do proper planning before we go and do operations? So first of all, we need to know exactly where we'll be doing our operation. And this is to know exactly where is the field of operation, to see what is in the surrounding area, to see what might be the possible risks and hazards in that area, and also to mitigate these risks and hazards. Before we go out for practical, this planning is very, very important. Use all available tools to your disposal to actually get as much information for the operating area. So first of all, what I like to do is actually go onto Google Maps and see exactly where the operating field is going to be. Then I get as much information for stuff like elevation, what is exactly the airspace that we're going to fly in and operating in, what will be the frequency that we'll be operating in this airspace, and also get stuff like coordinates. And this we can also see on these maps more or less what will be the risks and hazards involved. Next, what I want you to do is go and plot these coordinates on a map. And this might be, you can use Google Maps, you can use aeronautical charts, whatever it is you have to your disposal. Next, calculate the maximum flight distance your drone can achieve. Okay, so more or less how you can do this is to calculate distance. So distance is time times the speed of the drone. This will give you a max distance that you can achieve, the drone can achieve in ATI mode. And the reason why we do this is to see if, in case of a flyaway, we can see where more or less the drone can end up and see what might be the risks in that surrounding area. Next is take note of all your prohibited areas, danger areas, restricted areas, and get information on these different areas. Then also have a look at your controlled airspaces. So very important on the controlled airspaces in the surrounding area is get the contact number for the air traffic controller, get the frequency that they'll be using, and more or less see the distance from your operating site where you'll be working. Then also have a look on your ARPs, AICs and NOTAMs and see if there are any new updates. Next, have a closer look to your operating site. So get a close-up image on Google Earth and plot out exactly where you'll be operating. Plot down your takeoff and landing zone, plot down your setup area, plot down a ditching zone. A ditching zone we'll discuss a little bit later when we discuss the emergency response plan. But see also what might be the direct possible risks and hazards involved. Next is our risk assessment. Now, a risk assessment is we basically split into two. We have a pre-site risk assessment, which we use maps and what we use before we actually go out to the operating site to see and assess exactly what is the direct risks and hazards in the operating area. This will help with your planning your flight as well, to see where to avoid possible flight paths and also altitudes that you might need to change and operate at. Next will be the on-site risk assessment, and as it basically explains itself, it's something that you will be doing at the operating site. So the on-site survey or on-site risk assessment is basically because we have variables that change on maps. Maps can be outdated, there might be new risks that's coming in the short term, so we need to assess these possible risks. Now, before we go out and actually do the operation, we need to do a pre-flight inspection and setup. So the pre-flight inspection, this needs to be done before every flight that you do. Okay. So after you've set up your drone, you will do the pre-flight inspection, and this is where we basically look at the different parts of components of the drone to assess if everything is working to standard, everything is ready for us to go out and do the actual flight. Now I want to run through a few components of the drone itself, a few of the obvious ones, like our motors that we have, the props that's set up here. We also have a few LEDs that's going to indicate different scenarios on the drone or different problems that we might experience. So we basically have 3 different blinking LEDs or strobes at the back of the aircraft. The first one is green. So if you see the green LEDs at the back, this means good to go, all systems are operating. When we have a yellow flashing LED at the back, this basically means that we have some of the components that's being turned off, so we need to fly with caution. Next is red LEDs or red flashing LEDs at the back, and this means land the aircraft immediately. This can also mean that you have reached low battery, so bring in the drone for landing. Other components that might be totally switched off and might pose risks for the flight as well, so this will also mean bringing in the drone immediately. On our remote, we have 2 joysticks or 2 sticks that will help us manipulate the different maneuvers and controls on the aircraft itself. For us, we usually use mode 2 controls, meaning our right stick will be our pitching forward, pitching backwards, right roll, left roll. Our left stick will be our yaw or rotating the nose left and right, and then throttle up and throttle down. On the top left corner, we have our different mode switches. Now, different aircraft have different mode switches. The P mode, which stands for position mode. This is basically where the GPS is activated. So meaning the drone will maintain its location. Next will be ATTI mode or attitude mode. This is where the GPS being deactivated. So because the drone doesn't have any GPS connection, it will not have its location, so it can't correct for any drift. So when we're in ATTI mode, you need to apply or counteract for drift that the drone might experience. It will still have its barometer that will be working, so it will still maintain its altitude. And then the next last one is function mode. This is what we use usually in autopilot systems and also third-party apps. Now, after the setup, we've gone out, set up the aircraft, we will do a pre-flight inspection. Now, the pre-flight inspection needs to be done before every flight. And this is basically where we go through each component and we can see if everything is working properly and we don't experience mid-flight problems. So, as I said, pre-flight inspection before every flight. After the flight, you will then do a post-flight inspection as well, to see that none of the components been changed during the flight, nothing is broken as well, so that you are ready for the next flight as well. Which brings me to the next topic, making a radio call. So guys, when we make a radio call, all radio calls follow more or less the same structure. So first we need to address who we will be calling to. For us, it will be Johannesburg Special Rules West, where we are operating. Next, identify yourself and with your registration. So whatever registration your aircraft are, you're going to use that registration. So for example, Zulu Tango Alpha Bravo Charlie. Next, you need to identify what aircraft you'll be using. Because we are actually in the air with other manned aircraft, we need to let them know exactly, listen, we are flying a drone and not a manned aircraft. So after you've just told them what aircraft they need to be looking out for, you will let them know exactly where you'll be operating. Okay. After that, what altitude you'll be flying at, and then what is your endurance, or how long will you stay in the air for. So after the flight, you will then make another radio call to let them know that you are complete with your operation. I want to chat to you guys about post-launch in-flight procedures and maneuvers. So first we will discuss actions after a motor failure. In the case of a motor failure, all attempts should be made to bring down the drone safely into the designated ditching zone. The ditching zone is an allocated area that should be clear of all obstructions or objects or people to avoid damage or injury to anyone. Next, rights of way. When considering rights of way, the laws and regulations are set out in such a way to give rights of way to less maneuverable aircraft or high-risk aircraft like manned aircraft. So always follow the rules and regulations set out by the SACAA. Procedures after a flyaway. Now, a flyaway is when your aircraft loses C2 link with your remote. This causes a drone to take off and fly into a certain direction. So how do we prevent a flyaway? Now, first of all, set your home location before takeoff and calibrate your device. This will help mitigate any risks of potential flyaways. Now, in the case of an actual flyaway, the following procedures should be followed. First of all, try and regain control of the aircraft and initiate return to a home. Next, if this fails, then make a radio call and inform the surrounding traffic of the situation. Then establish the direction in which the drone will be flying, the altitude and also your endurance and speed. Then contact the closest air traffic service units and inform them of the situation. After all of this has been done, try and reconnect your C2 link. This is very important so that you can try and regain control of the aircraft. Now, what is return to home? Return to home is a fail-safe that we use to bring the drone back to a home point that's been set beforehand. A location of coordinates that the drone will save, and then if something were to happen, the drone will come back to those coordinates. We can also use this if we have a loss of visual line of sight or if we have a loss of orientation. Now, most important aspect of all operating procedures, all operations that we do is safety. So therefore, it's very important to have an emergency response plan before all operations. Now, when you do get an emergency response plan or plan for an emergency response plan, get first of all information on the closest police station, fire station and hospital. It's also good to have the contact numbers and address for this especially, and then also getting some directions for the operating site to the different police station, fire station and hospital. Then, as earlier discussed, the ditching zone. The ditching zone should be close to the operating site and not pose a risk or hazard in case of a crash. Then finally, I want to chat about the practical training. Now, the practical training is set out into different phases. So we basically have 4 phases. The first phase, which is exercise 1 to 7, will be basic briefing. Next, phase 2 is basic controls. This is where we will go through the different controls of the aircraft, moving forward, moving right, left, backwards. This will also have exercises like doing a window, or flying a window, so vertical square, horizontal square, flying a horizontal square nose in. Next will be phase 3. This is basic maneuvers. This will include exercises like takeoff and landing, flying a box, or what we call a box, where you will be yawing over each cone and then hovering the aircraft in anti-mode. Then phase 4 will be more advanced maneuvers. This will include exercises like horizontal ascent and descent, level turns, speed control, and flying a point of interest. Guys, thank you very much for watching. Please follow us on Instagram and on Facebook, and also you can contact us on the following.